Hey everybody, this is Larry. This is day 4 of the May Leetcode challenge. Let's get started on today's problem. Let me know what you think. Give me a like button. Give me a like. Hit the like button. Hit the subscribe button. And do whatever you like. Leave a comment on how you find this problem. Let's go. Number complement. Given a positive integer, output its complement number. The complement strategy is to flip the bits of the binary representation. Okay. Uh, hmm. This question is the same as another number. You can assume no leading zero in the bits integer binary representation. The given integer is guaranteed to fit with engagement. Okay, so I mean the quote unquote easy answer is to do something like this. But I guess the trick is, or the one thing to note is that doing this will give you the complement in 2's complement. And that'll give you the entire thing. So this would give you some like huge number for 5 and 1 and so forth. And you could even see this for yourself. So I'm just going to do it for science, which is kind of not what you want because, well, yeah, because that was a flip the sign bits. But the thing to what we want to do now though is we could do this with a for loop, which to just calculate the number of binary bits you need and then subtract it from the bigger one. Yeah, let's do that. Okay, let's just start with some k is equal to 1, while k is smaller than or equals to num. Yeah, left shift by 1, oops, left shift by 1, which is multiplied by 2. And then now we just return k minus 1 minus num or something like that. But I might have to double check the edge cases, which is near the things. Let's just try a lot of numbers as a result. Oh, did I not increment? Yeah, I incremented. Okay. So yeah, so that looks relatively good except for the 0 answer. I thought I was worried a little bit about that. Maybe I needed this. No, that doesn't change anything. But because 0 is a weird answer as a result. Oh, that should not take that long. 0 is a weird edge case because you could consider it having 0 bits and also 1 bit, right? It's depending on how you want to define it mathematically. So I'm going to just special case that for that reason, because it's a little bit tricky to. I mean, the definition varies a little bit, and now there's pending because I suppose because everyone is I don't know, submitting or something at the popular time. Refresh this. Oh, but now I should have copied the test cases actually. System seems to be a little bit, I think 9, 32, 31, some big numbers, some close to powers of 10s, powers of 2s, I mean. And again, that's one and once more. And everything looks okay relatively. No off by 1. So then let's go. Let's submit it. Unless there's negative numbers, then I'm a little bit sad because I actually did not consider negative numbers, to be honest. Okay. Oh, given a positive integer, but okay. So it can, yeah. Oh, I guess 0 wasn't in the input, given that I had the wrong answer. So I actually may not need this because it's a positive integer, but I wasn't sure. Okay. So yeah, so the reason why this works is just that it counts the, in a way, this gets the next power of 2, and then this is the complement. So actually, you could even look at this as this is the same as this as a result because this will give you a power of 2, So you could look at this number k at every point will actually be, like some. This is the binary representation, and then k minus 1 will be all the ones, and then the negative will just be like subtracting, So that's how you get the how I got the answer from the subtraction earlier. I mean, it's the same because this is all off by 1, but exclusive was probably more thematically correct, I suppose. But yeah, but that's pretty much it. That's how I solved this problem. And you could obviously there's a number of ways to solve this. You could actually just convert it to binary and then count the number of bits and then do it manually. But that's the way I kind of did it. Some of that is a lot of practice on bit masks and bitwise operations in general, but I don't know if it's that necessary, to be honest. But yeah, let me know what you think. Let me know how you approach this problem. Did you use binary? Did you use more library function? Did you do funky stuff like maybe I did? Let me know. And yeah, for this interview, this question, and then I don't know if it's probably a little bit too weird to be an interview, but it's still stuff that I feel like a lot of people are trying to get better at it. So definitely use this as an opportunity to practice. And yeah, and really cool. I will talk to you tomorrow. Bye bye.